Hello everybody, or those who survived. It was an amazing 2 days of the conference and content, and I'm going to be talking to you about something I've been passionate about lately, and it's animation. But before we talk about animation and start animating things in our UIs, I thought that maybe we can get animated a little bit ourselves. I know it's been also long 2 days, and I've seen some of you falling asleep. So I thought it would be nice to do a little bit of stretching. So I ask you to stand up. Nice, nice. Put your laptops away. Yes. Perfect, perfect. Now raise your hands and stretch a little bit. Up, up, up. Oh, it's nice. It's good for you. Yes. And then just a little bit to one side, not to hit your neighbor. Now another side. Perfect. Now just like shake a little bit. Maybe you roll your head. I don't know, whatever feels good to you. Nice, nice. Okay. Yes, you can sit down now. Okay, are you ready? Do you feel animated? Yes? Okay, great, and let's start. Let me quickly introduce myself. Hola, my name is KATERYNA. I'm Ukrainian, and I live in Estonia right now for the last 6 years. And this is my 4th time here in Alicante. I'm really excited to be here, and I work remotely at a company called Buffer, where I drive our front-end direction, and we generally have a lot of content to cover. So I will start the introduction right here, and let's start. In our web interfaces, most changes and actions happen instantly. You click a button, and then boom, new content almost teleports on the screen. But that's not how things work in the real world, right? Changes in state usually involve some kind of motion, and our brains are wired to understand it as we've been seeing the physics of the world around us our whole life. And this can make interfaces, by contrast, feel a little bit mechanical and disconnected from how we naturally expect things to behave. And animation can help bridge that gap. It can do powerful things to make interfaces feeling more tangible and real. For example, this is the Photos app. You can see when I tap on the image, it almost grows from exactly where I tapped. It does look nice, but also it has a user experience benefit because it creates a clear connection between my action and the result. You understand immediately what happened and how to get back. There is another one, fun one. Every time I log in into Netflix, I really enjoy it. You know how the avatar scales back directly into the position in the toolbar. Again, it looks nice, but it also communicates where you can access that information again after you've logged in. In the calendar, when you change the weeks, you can see it sliding, and it helps you to understand, giving you some visual feedback about the direction you're moving on in time. Animation also are really good to give feedback to users. Our brains are wired to detect motion, so animation can be a powerful tool to grab attention. This is how Figma uses it, for example, when you try to dismiss a comment. Or look how Airbnb highlights information for customers when they're searching for properties. The fact that these little badges are animated really immediately grabs your attention. Additionally, animation can always just be used to add some joy, whimsy, and delight to the UI. Like these 3D animated icons in Airbnb. Honestly, they look so enjoyable. Sometimes just switch between the tabs to see the animation play out. Or this character animation of Notion AI. These moments might seem small and insignificant, but they can also create a personal connection between the user and the product, and help people feel joy when they're using something that you've built. And you want your users to feel joy, right? So in this talk, we're going to talk about how we can create moments like this in the interfaces we've built. And as developers, we have a lot of tools at our disposal. We can use CSS, JavaScript. There's a lot of web APIs like Vue Transitions and different libraries. And I'll try to walk through different options and give you like a tour of the ecosystem, hopefully by giving you like around 20% of the information to get you 80% there in making animations in the UI. And first, let's start with CSS animations. This is the most accessible tool for animation we have, and it sets a really good foundation for everything else we're going to cover. The simplest type of the animation in CSS is transitions. When we have a property that's changing, like opacity here, we can add a transition and browser will animate it. Here we are saying transition opacity, and when it changes, do it over 300 milliseconds. And now, when the card is hovered, the opacity will be animated. The browser works by taking our start and end values and then calculating all of the intermediate values needed for each frame, and then apply those smoothly over the specified duration. This process is also called tween animation, from in-betweening, because we are calculating all of those in-between states. And normally we can animate any property that can be interpolated, like transforms, width and height, colors, and more. And talking about transforms, it's one of the most useful tools in animation, so let's quickly go over how we can use them. Transform property lets us move, scale, rotate, and skew elements without affecting the document flow. By the way, we now can use the individual properties for translate, scale, and rotate, which I'll be mostly using throughout this talk. They have been already widely supported in the browsers. Let's start with translate. What it does, it moves elements around. We can imagine our element on X and Y axis, and X value will move it left or right, and Y will move it up or down. Interesting thing is in these coordinates, Y works a little bit vice versa to math coordinates, so positive values go down. And an interesting thing about transforms is how percentage value works. If you provide a percentage, it will be relative to the element's own size and not the size of its parent, which is relatively uncommon in CSS, where most of the percentage values typically refer to the parent size. And this quirk actually enabled this old centering trick. You probably remember it. There was like a way to center elements back in the day. Right now we have a more modern tools, of course. But the way it works is that we position the top left corner of the element to the center of the parent, and then shift it back by half of its own dimension to center it perfectly, regardless of its size. Now let's look at the example. We'd like to implement the hover card that displays additional information on hover about a trip like this. Currently, we already have everything absolutely positioned. So what we can do is just shift our details by 100% of its own size to the bottom. But right now, you can see there's still a small piece that sticks out. To address it, we can include the margin in our calculation. And now the element is positioned out of the view. We also want to hide it. To do it, then we can add overflow hidden. And now we can actually animate it. So we need to change the translate value when the card is hovered. And then to animate it, we can just add a transition property. Now you can see when I hover this card, our panel smoothly slides up from below, revealing more information. Of course, with animations like this, we also need to take into account keyboard navigation as well. So since it is a link, I'll add here focus visible so that this animation will play out when I focus on the card too. In addition to translate, another useful transformation is scale. It scales elements relative to its own size. And one really common application for it is scaling buttons down when they're active. And it creates a really useful feedback loop. You can compare these two buttons. When I click the first one, I almost feel like nothing is happening. But when the second one scales back a little bit, it responds to my interaction, gives me immediate feedback on the action that I'm doing. One really powerful feature of transforms is transform origin, which allows us kind of define the pivot point around which the transformation happens. By default, it is in the center, but we can move this corner to any specific position on the element or even outside it, and therefore then transform it relative to that position. One really useful application for this is when in drop-down and different popovers. For example, you can see here a comparison of drop-down going from the top left corner and from the center. Notice how it almost feels like the one that goes from the button, almost like the button spawns the popover and creates a more connected experience. And one thing that with all these transforms, while they're extra helpful for the animation, is performance. Here's how the browser's rendering pipeline works. First, our JavaScript code runs. Then, browser figures out which CSS rules should apply to which elements at the style stage. Then, it does the layout, which basically means it calculates the size and position of every element on the page. Then, during Paint, it draws the actual pixels. And then, during the composite, it takes all of the painted layers and combines them. And animating different CSS properties can happen at different stages. And the further you animate down this pipeline, the better. Transform and opacity only trigger on the composite stage, which means it is the cheapest iteration that can be handled by the GPU. Animating color, box shadow typically triggers Paint, which is the next best thing. And then there's a lot of animation properties like width and height, font size, margin, and padding. It will trigger the layout, meaning that browser would need to recalculate positions of all of the different elements in case your change shifted them on every frame of the animation, which can be quite expensive. I don't want this to say to scare you. I think it's OK. Modern browsers are incredibly fast, and sometimes we genuinely need to animate height or width or other layout properties, and that's totally OK. And we just need to test in the performance tab and see how it works. Now, on the CSS animation, one really useful tool we have is timing and timing functions. And this can really affect how animations look and feel. When we set a transition, we can also provide a property to define the timing function. And there's 5 timing functions that are built in and supported by default. And ease is the default one that we've been using so far. Here's a good example. You can see 4 drop-down menus opening at the same time. And you can perceive that some of them are opening a lot faster than the others, but they actually use completely the same duration of the animation. It's just that the timing function is different. Here are the built-in timing functions on the timeline. You can see that linear moves on the constant speed. Ease one, that's the default, starts fast and then slows down towards the end. Ease in starts slow and then speeds up, and ease out is the opposite. It starts fast and then slows down. And ease in out combines both. Basically, it is a slow start, fast middle, and then slow end. Additionally to all of these built-in functions, we can also provide our custom function using Bezier curves. These work by defining 2 points with their x and y coordinates. And basically, these are 2 points that you can define the curve that the animation would go in with. I know that this might feel a little bit complicated. Luckily, for the most part, you don't really need to create these curves yourselves. There's a lot of curves that are already created. You can just copy and paste them and use them for your animations. There's this website called easings.net, which is a really good resource for comparing different curves together and seeing the extended set of easing curves. And there's also this really cool tool called Easing Wizard, where you can see all of these extended curves, and it also has an editor and preview for you to see how the animation responds to them. I typically like to save some of the extended values from the set as CSS properties, and then they're available and reusable. Now let's quickly talk about where some of the easing functions can be useful for what kind of interactions. Ease is a default, but for a good reason. I think it works quite well for a lot of the simple interactions, and it feels quite responsive, so it's pretty safe default. Linear moves at a constant speed, which is quite unnatural if we think about the real world. So main applications for linear are things like loading spinners, marquee elements, different loading indicators. So I wouldn't use it for any interaction-based animations, because it looks quite mechanical and slow. And I actually quite like the extended set of the ease out family. So all of these functions, they start really slow and then slow down. And it's really good for any click-based interactions because it makes the interface feel responsive, yet it is animated and there's some motion happening to help users understand what's happening. Here's an example, for example, between the standard ease curve and the ease out quint, which is a more exaggerated form of ease out. You see how the ease out one feels a lot more snappy. So the UI feels a lot faster. Of course, the timing functions are only part of the equation, and duration is also important. So we generally don't want animation to get in the way of users. And therefore, it needs to feel responsive and snappy so it's not slowing them down. I think around from 0 to 200 milliseconds is good for most of the smaller interactions, like opening modals and drop-downs and popovers. And sometimes you might consider not having an animation at all, especially if this is an action that users perform really often, because it can get annoying. And for larger interactions or more static animations, where user isn't blocked by the interaction, we can reach for higher durations, around 400 or up to 600 milliseconds. And this can help for animations to feel responsive, but of course, it all goes into the combination with the easing curve. You saw how the curve itself really affected how the animation feels. Now, as we've talked about transitions, there's another really cool tool that we have when it comes to the CSS, and it's keyframes. So transitions happen between two states, and keyframes allow us to create reusable animations with multiple steps that we can apply to any element. This is a simple example. We have a spin keyframes that rotate element 360 degrees. We can put it on something like a loading spinner. But then we can use the same keyframe on something else in a completely different scenario, like here, I'm rotating a React logo on hover. When we are defining keyframes, we can also create partial keyframes, where we don't need to define every step. In that case, elements' own styles will be used to fill in the gaps. Like here, for example, in the popover. By the way, the interesting piece, another piece here, is that you can see that, first of all, there's a different animation used for when it is open and when it is closed, but also a different duration. Because when we are opening something, user is already paying attention, but then when they want to close it, we sometimes want to get it out of the way faster, so the closing feels snappier. Remember that comment box example from before? This is also a really cool use case where we can use keyframes. We can add a little bit of jiggle by defining keyframes that moves our element and rotates it a little bit, and then repeat it a bunch of times. A nice thing here is that we can compact these definitions by repeating them with comma like this. And then we can just apply them to our popover, and now we have this nice animation. That looks delightful. It's like jiggle, jiggle. Another way we can use keyframes is to create coordination between multiple elements. Here's an example from Vercel's design system. They're a feedback widget. When you submit feedback, there's this beautiful wave of elements appearing, and it feels really nice. The way we can implement it is we have here 3 elements. We have checkmark, title, and text. We can apply the same animation for them, but then we want to stagger them, right? We want the next one to start a little bit later with a small delay. We can use animation delay property to specify it. But what you will see now is there's a little glitch happening, right? The checkmark animates OK, but then the title and text don't animate properly. They flip instead of sliding up. It happens because before the animation kicks in, the element already exists on screen with full opacity. And therefore, it just switches that opacity back. But we can fix this by using the animation fill mode property, which is actually super helpful for keyframes. It controls what styles are applied to an element before and after animation runs. Backwards is the one that we need here, because then the element will get the styles from the first keyframe before the animation starts. And now we have a beautiful, nice animation where you see it just fades down gradually and staggers beautifully. You can see a lot of these animations in my slides as well, where elements move up a little bit. Now that we've added quite a few intense animations, like the one with jiggle and the fade in, I think it's a good segue to talk about accessibility. Some people with vestibular disorders can have negative physical reactions to motion. Certain animations can make them feel dizzy or nauseous. The good thing is that most of the devices provide and let users choose their motion preferences. And CSS gives us a way to respect those preferences with the media query. I think it's important to understand which animations specifically can be problematic. So it's usually some large-scale animations and parallax effects, spinning motion and continued rotations, zoom and scaling animations, especially rapid ones, autoplaying videos and GIFs, and some rapid back and forth motion. That said, the opacity changes and color transitions are totally fine and safe. So it doesn't mean that we just need to go and disable all animations with this property. We just need to be thoughtful how we use it. So for example, we have this animation that adds a ping to help users find the start trial button. Apparently, animations like this can be quite taxing. So we can use the prefers media query. And I think one way to do it, which I often see, is that animation is just being disabled when the prefers reduce motion is set to reduce. But I would actually suggest going vice versa. We can instead apply animation only when motion is OK. First of all, it's a little bit less code for you to write, but also it's a little bit easier to support this going forward. And here's the end result, where there's no preference. We still have that ping. With reduced motion, it's static. But as I said, we don't have to remove motion entirely. Like in our drop-down menu example from earlier, we can just replace animation with something else that doesn't include a lot of motion instead of completely removing it. Now you can see here, by default, it still scales down from the button like we saw before. But then if I disable the motion, it just fades in. There's still a little bit of fade happening, so it's not very abrupt. But we don't have motion that can be problematic. Now that we've covered quite a lot of CSS animations, we talked about transitions and keyframes and transforms. I would love to talk about another feature that I'm super excited about, is view transitions. And view transitions are a web platform API that was pioneered by Chrome team. And by now, they are already quite well supported in different browsers. So they're already supported in the Chrome and the newest Safari, and are coming soon in Firefox. And the nice thing about view transitions, we can use them as what is called progressive enhancement, meaning that all the browsers would still fully work, but they just wouldn't get as smooth of the animation. You might have seen this demo with Astro, showcasing how really smooth these view transitions can be. You can see how elements slide into the new place when they're being open, and this is all powered by view transitions. So let's see how we can use them for our own apps. I have this carousel that displays tips for using view transitions. Right now, it's a little bit boring, right? I just click next and it just appears. We can make it a little bit more interesting. The only thing that we need to enable the view transition is just wrap our code that makes an update with document.startViewTransition in JavaScript. And of course, we need to take into account what if the view transition is not supported, so we need to add a fallback. And just by doing this, you can see that we have a nice crossfade going on. This is the default view transition that's provided by the browser. Let's see what happens under the hood. So when we run the JavaScript code and we trigger a view transition, our browser pauses rendering. And then it takes the snapshot of the current state before the transition, then executes the update, and then takes the snapshot of the state after the view transition. Then it compares these both snapshots, overlays, and animates between them. You can actually see this happening in the DevTools. If you slow down the view transition, you can see the view transition pseudo elements appearing in the DOM. And if you run the view transitions, you can also sometimes notice that some of the interactions become not responsive while view transition is happening. And the browser provides default styles, which creates this crossfade, but we can actually customize it. Before we go into the customization, I want to talk a little bit how we can use view transitions in React. Because React batches updates and applies them asynchronously, but browser needs, in order for all of that magic to happen, needs to happen seamlessly inside the callback. we need to wrap the view transition also with the flush sync to make sure that React will apply change immediately. We can, I know this code starts looking a little bit ugly, so we can abstract it away into a function or a hook, and then use it for our transitions, which I will be going on doing in the next slides. So the default crossfade is already nice, but I think we can create something more custom, like this zoom in and zoom out animation. So by default, browser treats the entire page as one transition called root. But we can give our own elements their own transition names and then customize them. We can do it by using this view transition name property. So in this case, I will call it the carousel tip. And then the browser will create a new view transition for it. And we can access it by using those pseudo elements. And then we can change the animation. You can see right now I have this zoom in and zoom out going on. And we can have multiple elements animating with different transition names in their own animations and timelines at the same time, in which case each one will animate with its own effect. We can make our animation a little bit more funky and create something like this. Isn't it look cool, right? It's without any JavaScript and fully powered by the browser's view transitions. But this is not the most exciting feature of the view transitions. I think they get really powerful because they allow us to morph between different elements in completely different places on the page. I have this video gallery up, and you see that these videos have thumbnails. And when I click one, it opens a full player. And right now, it instantly switches, but this is a really good application for the view transition. Ideally, I would love this thumbnail to gradually expand into the video player we have when we open it. The way we can do it is by using the same property like view transition name. The key with it is that it needs to be unique, so the browser can animate it properly. I can add the view transition name first on my video preview, and then if we add the same view transition name on completely different element on our video player, then we also would need to wrap our updates with the start view transition, as we saw before. And this should result in this animation. That was just a few lines of CSS. We didn't even need to do anything, just define the view transition names, and now they are animated smoothly. That looks nice. And you can also notice how the browser remembers the connection when you navigate back into the page. And of course, animations like this, when we morph different elements together, they can be quite taxing. You see there's a lot of movement happening on the page. So remembering what we learned about the accessibility, we need to make sure they're accessible. We can just disable all of the animations, for example, with the custom name. And then they wouldn't be animated. Of course, you can just wrap specific animations with prefers reduced motion as well. But the way view transitions can also work across multiple pages and in route changes as well. And React Router has a built-in support for view transitions. In order to do that, you just need to enable the view transition prop. And then it will tell the React Router to wrap this navigation with the start view transition function. And it also provides a lot of helpful additional functions and classes that you can use for the view transition itself. Another really exciting demo of the view transition is different lists where elements move around and switch. And this is super simple to implement. When we apply, first of all, we need to wrap, of course, with the start transition when search and filtering and deletion happens. But then if we just apply the same view transition name for our user cards, it kind of just works. So if I search, you can see that they gradually animate into the new places, like this. It works for filters, for the deletion, back and forth. It's quite nice. Of course, animations like this, you don't want to animate all lists in your application. It can be quite distracting, but it can be a really nice place for certain places. And one more thing I should mention is that React team is also working on the built-in view transition support. which works on top of this API that we just discussed. So you can already use it on its own, and then when it is released on the React side, then you can swap your users with it. And you just heard Chan's talk earlier today about it, so we'll be very quick. To adapt our demo before for React's view transition component, we just need to wrap the elements we want to animate with the view transition component, and then provide them a unique key. In that case, React will automatically generate the view transition names when the content changes. One important part is that React needs to know when to run the view transition. Therefore, it is typically run as part of any concurrent update, like start transition, or use deferred value, like here, or when we execute suspense boundaries. Now, with these changes, our demo should work in the React as well. Note that this feature is experimental, so it is not something you can use already, but I think it's nice to know what's coming and then be ready to use it when it's stable. And when it becomes stable, more frameworks like Next.js will officially support view transitions as well. And I think this is especially powerful when you're changing routes, because these are animations that are typically very hard to implement. All right, so we've covered a lot of CSS animation and view transitions, and these are very powerful tools, but they have something in common. They are all tween-based, right? Meaning that we define the start point and end point of the animation, and then add a duration. And then browser interpolates between these two values. And it works great for a lot of things. And with a more realistic easing curve, we can adjust how the element moves and behaves. But bringing back to our discussion about connection to the real world, if you pick up something and then drop it on the floor, you don't define how long it will take to fall, right? It will fall based on its weight, on the resistance, or the force you apply. So the duration is a result of physics and not something you predetermine. And CSS animations almost work backwards from that. So you can say work from here to here by exactly 300 milliseconds, regardless of that context. And this is where Spring-based animations come in. They're a super powerful tool to create motion that feels alive and responsive. This is why animations on iOS feel so nice. They're all executed with springs. Everything has a little bit of weight and momentum. So let's talk a little bit how springs work. Imagine your element that you would like to move is attached to a spring that's pulling it towards its target position. And the spring can have physical properties, like its stiffness. So a stiffer spring will pull harder, moving element faster and settling quicker. But if it is less stiff, then it would pull with less force. There's also damping, like the resistance or friction, but also the mass, how heavy the object you are moving is. And the animation is a result of all of these forces working together, and how the element accelerates towards the target, overshoots a little bit, or bounces, just like with a real spring. I don't have a lot of time to dive into the spring physics, but this is an amazing blog post from Josh Camus about the spring physics, and he generally has a lot of good content about animation as well, so I recommend checking it out. I want to talk about how we can use springs in React. There are several libraries we can use. We can use GSAP. There's also React Spring, which is pretty cool. And then there's Framer Motion, which used to be called Framer Motion, but now it's just called Motion. It is the same library, the same author, just rebranded. And this is the one that I want to focus on throughout this talk. It generally has really good docs. It also has a pure JavaScript version and a version for Vue. And the docs have a lot of examples. So if you get inspired for using React Motion, I really recommend checking it out. One big advantage of Motion is it's really intuitive and declarative API. The way it works is we just transform our regular HTML elements into Motion's version of those elements. And then they will provide us some perks. They come with some superpowers that we can use to animate them. For example, we can use it to make this toggle animated. So I start with a regular toggle. We can import motion in here, and then just swap our span for motion span. Then the only thing we need to do is provide an animate property, which defines how the element animates. Depending on its value, we'll move it within the toggle, and it animates. And look how nice it feels. It feels tangible, like it moves with a little bit of force, it has some bounce. But we have right now a little issue with our toggle. If the value will be set to on by default, it will animate when rendered. And sometimes that's the effect you might want, but with toggles, you probably want to disable that. Motion supports also an initial prop, which defines initial state of the element, and if we don't want to use it, we just set it to false. To really see the advantage of motion, look at the comparison of the CSS transition and motion here. When I'm quickly clicking on the toggle, you can see how motion 1 interrupts gently and then settles into the new position, where CSS animation is not interruptible. But these are like some basic Spring animations that we just did with toggle. I think one of the most powerful features of Notion are layout animations. And they let us automatically animate changes in size, position, or order without calculating anything manually. And they are really cool. For example, let's say you want to build an animated tabs component like this. If you were to do it from scratch in JavaScript, you would need to measure the width of each tab, calculate its position, animate that position and width, handle window resizes, recalculate everything when font size changes. It's a lot of work. Kevin Powell actually has a video on this, and it is 30 minutes long, and he's much better in CSS than I am. So it's going to take a while. But React Motion it actually makes it super easy to do it. We have basic tabs implementation here with radix, and we have absolutely positioned tab indicator. So all we need to do to enable layout animation is to provide a layout ID. We can provide layout itself, and then it will just animate the properties of the object, but layout ID works similarly to the view transition name we use for view transitions. And then we'll animate this object between different states. In here, when I switch between the tabs, the actual indicator is in a completely different place of the DOM, but it gets animated due to the shared layout. However, this animation has like a little weird issue, which you might have not noticed when it ran fast. But if we slow it down, you can see what's happening. You can see how the border radius kind of looks a little bit weird. It happens because of how motion works. Motion is quite performant, and it uses CSS transforms under the hood. And then it applies them to element while it moves. But it also makes distortions like this quite possible. And the border radius one is very common. However, it is quite simple fix. We just need to explicitly state the style within the element itself, and then it will animate smoothly. I think this is a drawback of such an intuitive and nice API that sometimes there is some magic involved and you need to dig a little bit deeper. But now with this change, it looks really nice. I mean, I actually like when it's like so slow. You know, it feels very like so nice and soothing. But now let's talk a little bit how we can configure the motion with React Motion. So we already talked about the initial and animate props, but we can also supply different settings in the transition prop. And we have two approaches to configure Spring animations. The first one is the simplified one, like you see right now, where we can specify the visual duration and bounds. Note that this is not the actual duration of the animation. It's mostly that by this time, the animation should be mostly complete, but it's not exact. Just because of how springs work. And then bounds controls how much overshoot we'll get. And then we also have the usual Spring physics available to us, which is a lot more configurable and powerful. We can configure stiffness and damping and mass, which will also affect how the animation looks. But it's a lot easier to look at it at the example, because this can take some time to build intuition around. So, for example, here we have our tabs from before. If I would change the visual duration, you can see how immediately it slows down. But then if I add bounds, you can see how much it overshoots. And it can really affect a lot how animation feels. We can make it more playful or more smooth. But then if we switch into the Spring physics, we have a lot more control We can control how stiff the spring is. The more stiff it is, the faster the element will get into its own position. Then we also can control the damping, which controls how quickly the spring stops oscillating, and then it makes the motion a lot more smooth. And then we can also control the mass of the object, which that's a lot, right? But you can see how by configuring all of this, we can create a completely different feeling animation, but it still feels very real and physical. And Motion has this tool called Motion Studio, where you can actually see all of these options yourself, and it's a great tool to explore. But generally, all of these take some time to get used to and to develop your intuition around them. So I would suggest just trying out and seeing what feels right. And then over time, you'll develop like a certain tricks and intuition around using these properties. As you've noticed, a lot of the animations that we've used so far have been quite distracting, right? And these are not very accessible for folks who have reduced motion on. Fortunately, Motion lets us disable all motion altogether just by supplying reduced motion preference to the one that the user has defined. And in that case, Motion will automatically disable all transform and layout animations, but it will keep animating values like opacity and background color. So it will animate everything smartly based on what we defined. With layout animations, you can create all kinds of transitions. We don't have a lot of time to go into more advanced stuff, but I hope I gave you a taste in what's possible with this. And really like this cool demo from Motion's docs with transition when we open a model. There is truly endless possibilities. One really fun use case that I want to cover really quickly is animating SVGs with Motion, because it's super simple. I use Claude, and I always notice this little subtle animation when I hover on the items, and it just looks so joyful. It looks very delightful. And it's something we can actually recreate super easily with Motion. Like if you have this success states, if we're using icons, like I really like Lucid, for example, when we export them, we get a raw SVG that we can animate. And the path is the normal HTML element as well that we can animate. We can just replace it with the motion path, and then we can animate it from like a full path, which will look something like this. That's nice, right? And it was just typically just 2 lines within the motion configuration. Of course, we can create a more complex animations. Here we have this check mark in a circle. And we can animate them separately, which is what I really like about Lucid specifically. It gives you full SVGs that you can animate separately like this. And with this, we just have both circle and check mark appearing simultaneously, which looks a little bit weird. So we can add a little bit of delay. And then I think it looks a lot nicer. The check mark, and then it gets rounded. And there's a lot of stuff that we can do with SVGs. Like, for example, these interactions created. Oh, that looks nice, right? Like, just like a subtle little motion. Ta-da. Yes. And the nice part is that it has an amazing community. And there's a lot of stuff that's already built. For example, there is this tool where there's a collection of already animated icons with motion. And there's also Animate UI, and there's also icons and components already animated in motion that you can just copy and paste into your app. And Motion is an amazing tool, but it's also a separate library that you need to be cautious about including, because it does affect the bundle size. But it can provide us a way to create a really realistic and delightful animation that we are not able to do otherwise. So throughout the talk, we've covered already quite a bit. We talked about CSS transitions, view transitions, and springs. And CSS is generally a really good default. It's really performant, well supported, and it can handle majority of our needs, especially for more simple or standard animations. View transitions are really cool, and as they're getting more and more supported by the libraries, this is a really easy way to create great transitions between the pages, and then all the work is offloaded to the browser. And these transitions would be otherwise really expensive to implement. And then for a little bit of extra oomph, we can use Spring-based animations with motion or other libraries. And while it adds a little bit of bundle size, it can create motion that is interruptible and feels really natural and real. And so if you want to create something a little bit more sophisticated, this can be your best bet. And I hope throughout this talk you got a little bit inspired to add or like sprinkle a little bit more animation throughout your product and learn a thing or two about animation. And thank you so much. And thank you as well to Victoria and Nacho for making this amazing event. And yeah, that's it for me.